Hi everyone, welcome to lecture 3. So where we stopped off last time in lecture 2 was discussing the signal to noise problem and the issues that we have in reliably extracting information at late times from correlation functions. So today what we're going to focus on is, since we can't go out very far in Euclidean time where excited state contamination is automatically reduced just due to the exponential suppression of higher excited states. So since we can't do that, we instead would like to be able to extract our signal earlier in time before the signal to noise issue pops up. And so the way that we can do that is by trying to maximize the overlap onto the states of interest. And then we don't have to go as far out in Euclidean time. So in order to create good operators, first we have to understand the different types of excited state contamination so that we can try to minimize the overlap onto the states that we're not interested in and maximize overlap onto the states that we are interested in. It also gives us a sense of how far out in Euclidean time we might need to go in order to reduce these contributions from excited states to a reasonable level. So when it comes to two-body physics, we have to consider broadly two different classes of excited states. So the first is just if we consider that we have two particles, 2 point particles in a box, and we know that the energy levels are quantized, and these are the things that we're after. And therefore, we're going to have, for any given state, excited states corresponding to elastic scattering of those two particles. So, for example, if we're interested in the ground state, then we might have a first excited state that contaminates the ground state correlation function, where our two particles have back-to-back momentum. So 1 unit of momentum in lattice units of 2 pi over L. And we would also have a contribution from 2 units of momentum back-to-back, etc., all the way up to the highest allowed momentum in the box. And then the second type of excited state contamination is just the excited state of a single nucleon. So rather than just having a nucleon scattering with a proton, we can have an excited state of a nucleon scattering with a proton. We can also have an excited state of a proton interacting with a ground state neutron or an excited state neutron, etc. So there's a whole tower of these states. And we can also have combinations of the two, so we could have an excited neutron scattering from a proton in the n² = 1 scattering momentum.